Your Spring Boot applications deserve a top-notch package. And so, in this video, I will give you 6 tips to improving the container images for your Spring Boot apps. You may already be using some of them may be new to you, but the best thing about all of these solutions is that they are compatible with any application. Plus, they are super easy to implement, so you can try them out right away. Tip number 1. Use Docker multi-stage builds. Each command in a Docker file creates a new layer. If all of these layers are added to the final image, it can get bloated. To keep your final images clean, you can use Docker multi-stage builds. They enable you to use several from statements in a Docker file. Each from statement uses its own base image, and you can copy only those artifacts from the previous stage that you need. The final layer won't contain the layers from the parent images, tools required for building the application, or files that weren't explicitly copied. As a result, the final image will be smaller. Tip number 2. Choose a small base image. Reducing the size of container images will help you to reduce the drive space and network traffic in your clusters. So the easiest way to cut down the size of your container images is to use a base image based on a minimalistic Linux distribution. There are several popular Linux distributions for the cloud, and their size may vary. For example, let's compare the size of 2 container images. One of them is based on Liberica JDK Standard and Debian. Liberica JDK is recommended by Spring, so I will be using it as an example. The container image with Debian takes 386 MB. And now let's use Liberica Runtime Container based on Liberica JDK Lite, optimized for the cloud, and minimalistic Alpaquita Linux. This container image takes 195 MB, which is almost 2 times smaller than the first image. Tip number 3. Opt for a layered jar for efficient caching. A traditional way of building Spring Boot container images is to use a fat jar. A fat jar contains the application with all of its dependencies. But each time we change the application, we need to build a new artifact. Plus, pulling the container images of the application with all of its dependencies may take time. Spring Boot makes it possible to create layered jars. In a layered jar, the application and its dependencies are stored in different layers. The most frequently updated layers, such as the application layer, are placed on the top in the container image. So, every time you introduce changes to the application, only this layer is changed and the others are pulled from the cache. And so the updates will be faster. Tip number 4. Upgrade the JDK and Spring Boot versions. Java Virtual Machine, the heart of the Java platform, is getting more powerful with each JDK release. Brand new features, improved features, numerous enhancements to the garbage collection, JIT compiler, and the intrinsics can make your application run faster even without code changes. Spring Boot also gets numerous improvements and new features with each release. For instance, Spring Boot 3 includes baked-in support for GraalVM native image. Spring Boot 3.3 includes support for AppCDS for faster startup, and Spring Boot 3.4 offers a smaller base image for build packs. These are only few examples of how your favorite framework can help you boost the performance and reduce the memory footprint of your container images. So, updating the JDK and Spring Boot versions is essential to keep up with the performance requirements for modern applications. Tip number 5. Enable AOT and CDS for faster startup. If application startup time is critical for you, consider using application class data sharing and ahead-of-time processing. AppCDS and AOT enable up to 50% faster startup of applications, and there are no need for code changes. Take Spring Pet Clinic, for example. It starts in a little bit more than 4 seconds on my machine in a container image, but with AppCDS and AOT enabled, it starts in less than 3 seconds. Note that the container with the CDS enabled will be bigger than the usual one. Plus, if you need more drastic startup reduction, consider using GraalVM native image or coordinated restore at checkpoint. Tip number 6. Consider using build packs instead of Docker files. Writing Docker files is difficult and error-prone, and plus, maintaining them might be challenging. Besides, there is a risk of using outdated versions of base images if you don't update the Docker file on a regular basis. Build packs can help you solve these issues. They turn the application source code into a production-ready container image, and all you have to do is run just one command. And build packs always use the latest version of software for base images, so you will always be up to date. And by the way, build packs for Spring Boot automatically create layered jars, so you don't have to do it manually. But of course, you can configure build packs. It is really easy to do. For instance, if you want to use AppCDS and AOT processing, all you have to do is to specify these two features in a configuration file, and that's it. The build packs will do everything for you. In this video, we looked at different approaches for optimizing the Docker container images for Spring Boot applications. If this video was useful to you, don't forget to like it, subscribe to our channel, and until next time!